Hello everyone, my name is Tumbiak Judone and I'm a student studying mechanical engineering.
Hi everyone, I'm Nancy Wang. I'm doing geomatics engineering.
Hello, everyone. My name is Moses Kimiji. I'm studying geomatics engineering, masters.
Hi everyone, my name is Afimi Ahiza Khalid. I'm doing a master's in civil engineering. The case summary. Our case is about the Macondo well Deep Horizon explosion. On 20th of April 2010, the Deepwater Horizon oil rig exploded in the Gulf of Mexico, killing 11 people and causing the largest marine oil spill in US history. The disaster was as a result of a series of failed decisions driven by cost and schedule pressures. The case summary. The BP was 43 days behind schedule, losing 1 million per day renting the oil rig. The pressure test results showed problems but were misinterpreted. Critical safety measures were bypassed. 6 centralizers were used instead of the recommended 21, which the simulation recommended. Blowout preventer failure due to uncentered pipes and wrongly positioned shear rounds. 4.9 million barrels of oil spilled over the course of 87 days.
Okay, now moving over
Biases.
to the biases present. The first bias that was faced in the Deepwater Horizon was the overconfidence bias. So the engineers and the managers that were on the rig, they were overconfident in themselves and they believed too much in their experience, and so they thought they could not make any mistake. So it caused them to overwrite the sorry to overwrite negative pressure test results, and they believed in themselves, and which eventually led to complication and disaster.
The second bias we found here would be the financial and organizational bias. As the accident happened, BP, the company, had encountered a 6 weeks behind schedule and 58 million over budget. This directly caused they made the decision that they will skip some some key safety checks, including the cement test, which is the direct cause of the accident. So this reflect to the financial and organizational bias that the the financial burden and the organizational heritage will be affecting the the safety of the field.
Another bias we have here in this case is the confirmation bias. At Deepwater Horizon, BP and Transocean teams, they misread the pressure test data that indicated that there's a well integrity failure. Instead of stopping operation, they chose to interpret the data to confirm their belief that it was just a blunder, right? It was just some false negative. And so some of the breakdowns we have here is that, you see, they ignored contradictory evidence, like engineers selectively trusted safe readings while dismissing warning signs, right? They evaluated professional integrity, like the duty of objectivity was replaced by convenience and production pressure, like this, to get up with time because they were running out of time and spending a lot of money. And this eventually eroded the public trust, like they prioritized economic goals over safety goals, breaching like the APEGA Rule 1, like this, we have to, as engineers, we have to protect the public interest. So it's like more of this is the fact and evidence. We ignore that. So we use our belief and some part of the evidence that we have to confirm what we want, how we want that particular situation to go. So confirmation bias arises from the desire to avoid conflicts, like, so to meet deadline or align with authority. So we engineers are just choosing comfort over critical truth.
As for the system issues presented in this case, we found three failures. The first one is the organizational failures, as what we have talked before in the bias section. The poor communication of them among the different companies and the bossy management vibe that the company was providing. Uh, they combined provided a culture that the uh, the engineers won't talk up and they will believe that it will be fine. They just being overconfident. And the second one would be the risk management failures. Obviously, like for they didn't obey the safety procedure of the field um of the field work. So they didn't do certain safety checks. That is the direct cause of the accident. And the third one would be the regularity oversight failures. MMS, which is the organization that was responsible for the regulation, they lacked independence and expertise and funding, so that they have close relationship with these oil companies that was that caused them that they neglect the potential the potential causing of the accident.
Okay, moving over to the lessons learned. The Deepwater Horizon being one of the most catastrophic disasters in history, so there are a lot of lessons we can learn from this error. And the first lesson is not to ignore danger signs. And this is what most of the workers, the BP and Transocean, they ignored a lot of test results, and like we saw earlier, the overconfidence bias. So they had trust in their experience, and the tests were clearly showing abnormal results and warning, but yet they choose to ignore the signs. So one of the lessons as engineers is always to pay attention to any sign of danger, and always make sure that the data and every test is performed correctly and not ignored. The second lesson we're going to learn is not to sacrifice safety for money. Like in this Deep Horizon case, BP, they were already over 43 days behind schedule, and each day was $1 million France. So there was a lot of pressure from the management team to get the work done, and they had to skip a lot of standard procedures. Like, for example, they had to use six how did they call six centralizers instead of 21, and they skipped a lot of circulation tests, which eventually led to the disaster. So ethical engineering prioritizes safety and environmental protection over profit and schedule. And this is one of the lessons that we as engineers, ethical engineers, we should practice, not to sacrifice safety and for money. The third lesson is to speak up about concerns. So most of the crew members, they saw safety problems concerning the test, the cement test, and that was evident of a leak. But as a result of pressure and as a result of fear of losing their jobs, and they couldn't speak out to their bosses. So that eventually, if they spoke up and reported the concerns that they found, it would have probably avoided the disaster. So speaking up is part of being an ethical engineer, and silence can lead to a disaster. There are many frameworks for speaking up, whistleblowing, and most organizations nowadays have a lot of frameworks for internal reporting and external reporting to report any safety concerns identified in the organization.
So preventing another deep water horizon disaster. I mean, preventing future disasters requires like ethical culture that values integrity. We don't put companies' profit over human life, accountability, right? And also care, like care for the environment. So if we care a lot for the environment, we would consider it the damage that can be done when we are making certain decisions. So with these few ways, a disaster as big as Deepwater Horizon can be avoided. Thank you all for watching.